Now that we know a bit more about the MVC pattern, we're going to kick off the work for this module by looking at the layers under the actual view. So the model, the repository, and the controller. Before we start looking at the code, it's important to understand that ASP.NET Core MVC is pretty convention-based. That means that it will by default expect certain components to be in a certain folder or have a certain name. We'll come across this several times, but here is one already. By default, ASP.NET Core MVC applications use common folders for each of the building blocks. So you will typically see a controllers, a models, and a views folder in an MVC application. Know that these are conventions. Often you can change the configuration of your application so that it doesn't follow these conventions any longer. But we are building our first application, so we'll stick to these defaults. Let us start by looking at the first building block, the model. Now I have been referring to that model already quite a few times. What is it exactly then? We refer to the model as the group of classes that make up the domain data. So these are typically plain old CLR classes, also known as POCO classes. Next to the domain data, the model also contains the classes that manage the data. The latter would then typically be a repository class. More on that in just a second. The model should typically have a simple API, and its goal is hiding the nitty details of how we manage or interact with the actual data store from the consumer. We do not want to spread the code that does the actual data interaction throughout the entire codebase. We want to group that inside of the model. Like I said, part of the model is of course the domain classes, so POCOs. In our case, we'll need to represent Pi instances in our application. The model class Pi is a class part of the domain of the application. Here you can see the Pi class. I will be using this one in the demos very soon. The class itself has no base class. It is just a simple POCO class. Each Pi will also be part of a category, another class in the domain of the application. Just the domain classes alone don't make up the entire model. We'll also need classes that will perform the actual data persistence. This will be handled by creating a repository class, which is a class that abstracts away the details of how the persistence is happening. Freely translated, as mentioned before, we don't want to litter our code of the application with code that persists objects. All that code should be placed inside of a repository class, which can then be used from our application. I have said that the model should expose a simple API towards the rest of the application. Well, that is what you can see here. We're looking here at the contract of the repository called iPiRepository. This interface defines what our repository will be able to do initially. It defines a property, allPis, which is returning an I enumerable in Pi, containing probably all Pis in the data store. Next, it also defines a method getPi_id, which accepts the ID of the Pi we'll want to retrieve. Pretty simple, right? In the upcoming demo, we'll be creating this interface. In this module, we are going to be using mock data. We'll only link our application with a real database in the next one. Working with mock data for now can be done by creating a repository, and I called it a mock_pi_repository, which implements the interface, of course, that we've just looked at. And this can for now just return hard-coded data. Now, our repository class, so the mock_pi_repository, will be consumed by another class. Traditionally, what we'll do is creating an instance in the code of the consumer. This would, however, create a hard link between the consumer and the repository class itself. Remember that MVC was all about loose coupling, and here we are considering to create tight coupling. In the previous module, we have seen that ASP.NET Core comes with a built-in dependency injection container that allows us to resolve dependencies at runtime. We can register classes and their interfaces in the dependency injection container in the program class. The container works with built-in services, but also with services we create. Instead of creating an instance of the repository in our code, and thus creating a tight coupling, what we'll do is register our repository in the container. All other classes that will now want to make use of our repository can then ask the dependency injection system for an instance of our repository. This way, we'll create more loosely coupled code. Here you can see a snippet part of the program.cs. In the highlighted line, I'm registering my own repository, the mockpy repository, in the container using services.add_scoped. I pass the interface and the concrete implementation. The result of this call is that we can now, from anywhere, ask for an IPy repository, and we will from the container get back a fully instantiated mockpy repository. When registering items in the container, we have a number of options to do so, and they differ in the way that objects are created and how long they live, so in terms of lifetime. When we use add transient, every time we ask the container for an instance, we'll get back a new clean instance. The add singleton method results in a singleton being created for the entire application. Every time we request an instance, we'll get back the same one. Add scoped is another option, and it's the most commonly used one. Scoped lifetime services are created once within the scope of the request. Now, this might be a little more difficult to understand. Let us see that in a visual way. When the application starts, the services are registered within the container. Scoped services are registered so that a single instance is used while a single request is being handled. Say that a request comes in and an instance, an object that implements the IPy repository, is needed for component A. A could be, for example, a controller. The container will create a new object, probably a Py repository instance, and is kept alive as long as the request is being handled. If somewhere later in the handling of the request, another IPy repository instance is requested, say by component B, so still within the scope of the request, the same old one is reused, hence the name of the method add_scoped. When the request is handled and the response is sent back to the client, the object will be discarded.